Below much of Cape Town lies the Cape Flats Aquifer, which is an underground layer of sand that is completely saturated with water and through which water flows, in this case, towards False Bay. Imagine if the water in this aquifer was harnessed to supplement Cape Town's water supply to help avoid another potential day zero, as almost occurred during the 2018 drought. UCT's Future Water Institute and the University of Copenhagen, with funding from Dunedin, are collaborating to explore the potential of using existing stormwater detention ponds. Across Cape Town, there are approximately 850 of these ponds, and our research asks if these ponds can treat stormwater and recharge the Cape Flats aquifer to enhance possibilities of later abstraction through boreholes. Instead of approaching stormwater as a nuisance or waste to be rapidly disposed of, this research considers stormwater as a valuable resource and an asset which can be used to help the city build resilience to the impacts of climate change and support communities. We propose that existing stormwater detention ponds, basins engineered to reduce flooding in neighbourhoods during storm events, can offer other water management roles by providing opportunities for stormwater to seep into the ground and recharge the aquifer below, instead of flowing out to the sea. Such ponds could also become multifunctional to include biodiversity, amenity and livelihood support functions as vibrant green spaces, community gardens and so on. Our research focuses on the pond as part of a blue-green infrastructure approach using a natural recharge process. It adopts a nature-based approach that mimics nature's ecological processes of slowing, cleaning and filtering surface water runoff.
To take this approach, a stormwater detention pond was retrofitted to facilitate aquifer recharge and provide additional benefits like water quality improvement and amenity. A pond in Fulham Road, Mitchell's Plain, was selected in consultation with the City of Cape Town's Catchment, Stormwater and River Management Branch and the local community. The construction activities were impeded by the COVID-19 pandemic, but commenced in August 2021 with the consent of the local residents and community leaders. The local residents formed themselves into teams of workers to construct the retrofit elements with the assistance of a contractor who specialized in non-concrete forms of building. The construction was completed over a period of 3 to 4 weeks, and while COVID affected many local residents in terms of unemployment, the project offered a temporary source of income for some, as well as an opportunity to gain new skills such as sandbag construction. The work involved digging a 90-meter-long trench for infiltration adjacent to the 2 stormwater inlets into the pond, as well as building a sandbag wall along the trench to contain the water and create more surface area for infiltration. Most of the work was completed by September 2021, and we continue to test the flow of water through the system, the water quality and the other processes involved.
The groundwater is shallow and the soils become completely waterlogged during the wet season. This limits oxygen transport to the groundwater and creates conditions necessary for denitrification, that is, the removal of nitrogen. This is a key water treatment process. Another key water treatment process at the site is the attachment of contaminants such as metals and phosphate to soil particles. This means that the soil does some of the filtering for us. Monitoring wells installed across the pond at different depths allow us to sample the groundwater and infiltrated stormwater and monitor the water levels in response to rainfall and seasons.
Key to the research project is the involvement of the local residents and the neighbouring schools in the various activities. Apart from the construction, other activities have included a spring planting day that was facilitated by a conservationist, which involved children from the local schools, and a plant exploration outing to a local nature reserve. As part of a Restoration in Progress theme, those present were shown the plants indigenous to the area and their various benefits. The residents who worked on the pond noted that their attitudes towards the space had changed, with some explaining that they now saw the pond as part of nature and no longer just an empty, vacant space.
Other initiatives are underway that include the co-creation of a mural to showcase the project. For example, workshops where residents are contributing ideas and drawings focused on how they see the pond and its role in their neighborhood. More planting and painting days are also envisaged, as well as opportunities for co-design workshops with local residents focused on how they would like to design the pond space for their future use. The research is relevant in this context as it addresses several critical issues, including the need to diversify Cape Town's water resources by using existing stormwater detention ponds to harvest stormwater and recharge the aquifer. The project considers how maximum benefit could be derived from these stormwater management systems by adopting low-cost, easy-to-install blue-green interventions that rely on nature-based approaches. The research also provides some ideas for how to co-produce livable urban environments by involving communities in the retrofit of monofunctional stormwater ponds into safe, accessible, multifunctional green spaces.
In summary, we're finding that stormwater ponds offer tremendous potential as multifunctional blue-green open space, preventing flooding and harvesting stormwater to supplement the city's water supply, all whilst providing local residents with safe, secure green space.